Okay. So A, can someone talk to me about what they shared with their partner about A? Because it's asking you to explain what will happen. We have an X coordinate and a Y on each one. So what happens to this rectangle if this becomes the new coordinate rule? Kendra?
It would be 3 times as wide into the right 4 units. It would also be 3 times as tall, and it would move down 2.
So because the X and the Y are both being multiplied by 3, that changes the size. Anytime we multiply the X or the Y by a number other than 1, the size changes. So this is 3 times wider and taller. Then, like Kendra said, it's going to move to the right 4 spaces because I'm adding to the X. When I add, that doesn't change the size. It just moves it either to the left or to the right. This is adding, so it moves it down the X-axis to the right. So moves 4 spaces to the right. And the last thing Kendra said, because I'm subtracting 2 from the Y, and the Y operates up and down, if I subtract 2, it's going to move it down 2 spaces. So moves 2 spaces down. That's what this coordinate rule does. What do you know about the figure that we're going to make? What do you know about that rectangle if this was the coordinate rule? What else do you know? Like what happened?
It's going to get 3 times bigger.
3 times bigger, which means it's a similar figure. Has the same corresponding sides, has the same corresponding angles, and it's going to be the same shape, those 3 things. Talk to your partner about B.
B that you can't do.
It would move to the right 4 units, then become twice as wide. It would also move 2 down, then become twice as tall.
All right. Who would like to share what's going to happen here? Max.
I'm not raising my hand, scratching my head.
Taylor.
It would move the shape down to the right and to the left.
Now, you say it's going to make it bigger. Hold on. You say it's going to make it bigger. Why do you say this shape is going to get bigger?
Because we're multiplying the y-axis.
Okay, so there's multiplication in this y-axis. But here's my question. And I'm multiplying in the x-axis, right? Is this 2 being multiplied by the 2, or is it being multiplied by the y, or is the 2 being multiplied into both? Ben.
2 is, because you have to do exponents first, so it would be 2y. So you multiply 2y, and then
So you say, I have to do this multiplication first, right?
no, you do the exponent, and then,
But there is no exponent in here.
oh no, you
So if I just do multiplication and division first, I'm only multiplying these 2 numbers. I never take this 2 and multiply it into the y. There is no distributive property here. In order for there to be a distributive property, it would have to be written like this. I would have to have parentheses which say multiply the 2 by everything in the parentheses. But this 2 is in the parentheses. So the 2 is just multiplied by the 2.
Y minus 4.
Which is 4. So does this shape change?
no.
No. This shape's not changing. It's not getting bigger at all. All it is moving.
Run, Forrest, run.
Run, Forrest, run. So here, this becomes 4. This would become 8. X and Y stay the same. So this shape is identical. So I'm going to write that down. Identical shape. Because this is going to be 8, it's going to move to the right 8 spaces. And it's going to move down 4 spaces. And the reason why it's going to move down 4 spaces is because of that multiplication. But this 2 doesn't work on the Y because of PEMDAS. PEMDAS tells me, do the multiplication first. I will. Boom, there it is. There is no distributed property there. This was a common mistake. That's why we're doing this. I saw this quite a bit. C a little bit easier. Go and talk to your partner about C now.
So C is adding to the Y, adding on the number line, you move to the right. So if the number line was vertical, it would be going up, and then the x-axis, when you subtract from it, when you subtract, you go left. You just got mathed on.
So, I heard a lot of you say, this is twice as big. Reason why? Both my X and Y are being multiplied by 2. That changes my size. The only way I can change my size of an object in a coordinate plane is by multiplying my X and Y or dividing my X and Y. That will change the size. Adding only moves that object. So it's twice as big. It moves to the left because I am subtracting 2. So now on my x-axis, instead of going to the right like adding, this object's going to move 2 spaces that way. So this line will no longer be there. It will actually be right on the y-axis. And then I'm adding 3. So it's not going to get taller. It's going to move up 3 spaces. So before it was here, I know it's going to be on here, up 3. Now that corner is right there. And it's going to go up like this. And it will go over. Whoa. Hey, got a little ahead of myself there.
That's some cool homework.
Okay. So my next question for you guys. Is that talk to your partner, which of these are similar, which of these are identical, okay, and which of these is an imposter. Now, it might not be all of those. So, talk to your partner. What do we have up here as for shapes? Are they similar? Are they identical? Or are they imposters? Talk to your partner.
Maybe it's identical.
Yeah, I don't think you have. What if B is
A.
so this one?
Oh no. A is just making the shape 3 times bigger, color-wise and wider.
So is it identical? Is it an imposter? Or is it...
I think it's similar.
Okay.
Similar, and then C
And then-
is also.
What about B? We wrote it down. So A, what's A, Cam?
It's similar.
Similar, because both the X and the Y are changing at the same constant of proportionality. You see that, Lou? They're both being multiplied by 3. That's a similar figure. B, we already said what it was. Axel, what is it? Identical. All it is the same thing, just moved. Max, and what about C?
Similar.
Similar as well. Because 2 and y are both changing at the constant proportionality of 2. So which one are we missing?
Impossible.
How would I make an imposter? Talk to your partner.
A billion times.
You did that on yours.
Yes, I did.
You-
I very much like
a bi- I was like, had to be math. So James, how do we make an imposter?
And have both minus 1.
How do we make an imposter?
what Max said.
What did Max say?
A million. Fine.
Hold on. James,
What are you doing?
do you know how to make an imposter?
Yes.
Okay, go for it. Max.
You multiply like the x-axis
Yeah, I multiplied the x-axis by
like 5, I guess.
5.
And then multiply the y-axis
By a different number, right? That's an imposter. I'm changing the size axle, right? But it's not a constant in proportionality. This is getting really wide, but it's getting even taller. Okay. Talked to you about a couple other things here. So I worked way too hard on Friday, grading, and a lot of like old stuff. So I'm no longer accepting anything over a week old. It just, if you're missing, it's a 0. Okay? So I'll keep reminding you because I really want you to get in your missing work. But I'll send out those emails about every week about what you're missing. And if you choose to do it over the weekend, then you choose to do it. And then Monday it will be a 0 if you don't give it to me. Because it's really hard for me to stay on top of all of the missing work. So a lot of you, great job on getting the work in that I sent home over the weekend. I really appreciate it. I posted more grades and we had tests, right? We had the investigation 1 and 2, that's in there. Your reflections in there. Your homework's in there. The warm-up's in there. As well as your partner test is going in tonight. So I've got all that done. It's all going in. Retakes for quizzes. So retakes for quizzes will happen this week during lunch on Wednesday. So if you want to retake the quiz, okay, because you saw your results, you have to have this done. So you can grab it on your way out. Okay. You fill it in just like you would on a unit test or anything. We'll go over it and then you can take the quiz. This is to make sure that if you have misconceptions, I can help you with those and help you understand them before you take it again and possibly make the same mistakes. Any questions about those announcements at all? Okay. I can identify which triangles are reptiles. Talk to your partner about what a reptile is because this is what we're doing today. Go.
Yes, a bunch of Illuminati triangles put together to make another.
So we know that what we're doing today is we're using triangles. There are 4 kinds of triangles that we're going to use today. They are these. Scalene triangle, right triangle, isosceles triangle. That took me a while to spell right. And then equilateral. So these are the triangles that we're going to that we're going to work with today. What's a scalene triangle?
A triangle that's called a scalene.
Yeah, Liam?
A triangle where all the sides are different?
All the sides are different. What it does, it creates one angle greater than 90 degrees. So that's greater than 90. Right triangle. What's a right triangle? Taylor.
So one of the angles is a right angle.
Is a 90-degree angle, right? Okay. What's an isosceles triangle? Kendra, you know what an isosceles is?
I do.
Streeter?
2.
I can never remember.
Lulu?
Did you purposely make trying?
Whoops.
Trying.
You did for 2.
No, I was just, in my rhythm of misspelling. That's a common thing with me. You know what an isosceles is? It's
It has 2 same sides.
two sides that are the same, which then makes 2 corresponding angles that are equal. And equilateral triangle, Max?
It's a triangle where all the sides are the same length.
That's pretty close. Okay. So we're going to be using those triangles. Go to your template, and I want you to find those triangles.
Oh, we gotta go grab it.
Yeah, if you didn't grab one, you should have.
Oh, I didn't even see them.
Question for today. Why?
Can you find them?
Right triangle.
Yeah, here's a right triangle. Here's a equilateral.
This is the isosceles right here. Wait, hold on. Let's actually talk together because you're kind of giving me a brain hemorrhage.
They are gossiping about me.
Wait.
Yours is not.
Wait, so this is equilateral.
Okay, Cam. What's the number for the scalene? T5. Wait, I don't think so. It's T3. That's T3. What about a right triangle?
T1.
Axel?
T2 or T5.
T2. T5, there's 2 of them. Isosceles. Liam? T4, and then, of course, the last one, equilaterals, T1. So you're going to need those today, and I don't know why, but my computer's not working unless I... Okay. So, you can see, I've taken this right triangle. Please turn to 3.2 in your, for your notes. I've taken this right triangle. You should have 3.2 in front of you.
It's 3.2.
3.2, thank you. 3.2. I've taken this right triangle and I've used it to make a reptile here. So I've made the reptile. I have my original, or my original, either way. Oh, I forgot to erase those. So now, talk to your partner. What's the scale factor of this triangle from that triangle? Go, talk to your partner.
Okay, 2.
Write that down.
They don't even have it though.
Write it down. Answer it. So, I know, you got to make it. Scale factor equals 2. Please write this down because the sides got twice as big. It was only 1 length. Now it's 2 lengths. It was only 1 height, and now it's 2 units of height.
Wait, for the area, can we say what is multiplied by, or the actual area?
You don't know the actual area.
Yeah, I know. I'm too lazy.
Talk to your partner about the area of how much bigger is the area from here to here.
It's 4. No, you said it first.
Okay. So Lulu said it's 4 times bigger. You can see that, right? But this is what I want you to write down. The area is going to equal the scale factor squared. So you need to understand that because the scale factor is 2, 2 times 2, right, 2 squared, is 4 times bigger. So this is 4 times bigger than that. 4 times larger.
Yeah, that's right.
And the last thing is, how much bigger is the perimeter?
Twice.
It's twice as big because it's the same. I took the scale factor, I increased each side by 2, which means I increased the perimeter by 2 as well. So the perimeter is 2 times bigger as well. Have down those notes. Okay, make sure you have down the Make sure you draw your own. Okay, you can sketch it.
Why must I draw it? I'll draw whatever I want to draw.
Then,
I'm gonna get.
today, this is what we're working on. You're going to work on problem 3.2, page 45 and 55. Now, guys, 54 and 55. Thank you, Claire. Use the back of the sheet to draw your reptiles. This is the sheet I would like you to use. The back side of it is where we can draw our reptiles, which is part of A. Then, B. Okay, B, all answer this question on the front of the sheet. And then C, you can use the back to extend them. We have about 15 minutes because today's our short day.
Yay.
Any questions? Axel.
Questions of the day. Why?
Yeah, the original goes in that box, yeah.
Okay.
Okay, guys, I'm going to record your conversations today. Sweet. So, make sure you read the problems, talk out loud to each other, okay, to support the learning.
Okay.
Right on.
Let's see.
So, page 55.
Right? Oh, T2 and T5.
Okay. A. Which of these triangles is a reptile? Make a sketch to show how copies of the original figure fit together to make a larger and similar triangle.
Burn that bridge for me.
Okay, so first we have to use the back of the sheet to sketch a right triangle, isosceles, and scaling.
Yeah.
So right one, should we use T2 or T5?
Yeah. Well, the scaling is T3. And then the right triangle is T2 or T5. I'm doing T2.
Yeah.
And then
And if there isn't one there,
isosceles
then you're
triangle
going to have to share
is
with
T4.
Okay.
And the equilateral triangle is T1.
I don't think we need an equilateral.
Okay.
It doesn't say on that. So. Okay, which of these triangles is a reptile?
Well, can't they all?
Make a sketch to show.
So try to make a sketch to show how copies can be. So you have to make a bigger figure.
Okay, here.
Using the same triangle.
I'll try
T2.
Okay, I'll do the T4. T2.
What is wrong with mine? Mine's like
So you draw the T3 like that?
Even though that's not what this left side is. I don't care.
Okay then. Oh gosh. A right triangle.
I don't think there's any way to make T4 into a bigger triangle.
Okay. I think I got T2. Is this same right?
Yeah, that seems right. Here, let me just do that real fast.
Okay. And then, what one were you trying?
What did you?
I did T2.
Oh, okay, I see. I do that. Okay, yeah, that works. I was trying T4.
T4. Okay, I will try.
I don't think you can, but maybe you can. Think so. I'll try T5.
I agree. I don't think T4 is a reptile.
Yeah. And
So T4 is not a reptile.
Keep trying.
And then the other one was T3, right?
I think no, it's T5.
T5.
Or yeah, T3. Sorry. I don't know why I said T. I don't think this one works either.
I don't think it's going to.
It's such a weird shape.
I don't think it is a reptile.
Okay, so only T2 is a reptile.
So it says which of these triangles is a reptile, so T2.
Hey.
I'm just going to circle it. So that's A. Okay, look at your sketches from question A. Which is the scale factor from each original triangle to each larger? Explain your reasoning.
Okay.
So which is the scale factor? So we'd just be able to do cheat sheet.
Okay, so I think we're supposed to answer this one with this, aren't we?
Maybe. Use the back of the sheet to present your drawing. So B. All answers this question on the sheet you clicked at before. So yes, the front.
Okay.
Okay. Oh, wait.
Okay, so we need to sketch
I think we need to sketch on the back side the T5. T5.
Okay.
So let's see if it's a reptile.
Okay.
Last year for the recital, I could do all of my hairs except that. You're so lucky. I don't know if it's a reptile either.
Okay.
Do you think it's a reptile?
No, I don't.
I don't think it's gonna work. So, not. And that's T5. Okay, and that, but they have to be reptiles to be able to find out the scale factor of the area. Well, I guess not.
So what?
Well, It says, what is the scale factor from each original triangle to each large triangle? Explain the reasoning. But only one. Or,
But I wanted you to, because I wrote notes after different.
Well, so the first one, the scale factor is 2, the area is 4, and the perimeter is 2 times as large. But
let's just work on T2 for now, and then we can figure out what to do.
well, I guess they are supposed to fit.
We can keep trying.
Now on T1, right?
I guess this might work right here. I'll work on T4 if you want to do. T5. Okay, they are right there.
Got it?
Yeah.
Yeah, okay.
I mean, it's upside down, but oh well.
And which one was that? T4?
Yeah, that's T4. So I guess I'm not going to answer.
And you just did 3 and then 1, right?
Yeah.
Okay.
I just kind of alternated them. So I guess I'll put this down as a reptile.
And I made another triangle just as so yeah.
I'm going to have to turn this one sideways because it's so.
That is one of these was this and very big. Oh, bro, you ready?
Huh? It's T3. No, it's T3, I think. It's also those.
Oh, no. I remember.
All right, guys. Tomorrow you're going to have plenty of time to do your independent practice. But today we are out of time. You need to put 3.2 in lab sheet 3. These 2 sheets should go in your learning, and they should be side by side. We will look at 3.3 tomorrow. It's a slight extension onto 3.2. And we'll work towards it. Just so you guys know what's coming up, we will have, I will be assigning reflections for Wednesday. Okay, that will be the homework. We'll work partly on it, and then Thursday, you'll be assigned those for homework. Next week, we have a unit test on Thursday before Thanksgiving break. Okay, I will be on the 12th. That's when I will assign the unit review. Okay, and you'll be asked to work on that over the course of that week to get ready for the test. Today, please get your planners out. We have 4A, 4B, 4C, and 4D on page 61. Today, our I can statement. It was all about using the 4 triangles, the scalene, the right triangle, the isosceles, and the equilateral to build a reptile. Okay, creating that scaled version. So because of that, we're going to look at a reptile which has a right triangle as its base unit. And then I would like you to answer these 3 questions. Write down the scale factor from the original, and please write in complete sentences. So you should have number 1, the scale factor is, and then number 2, how does the perimeter change from the original to the scaled up reptile? And then number 3, how does the area change from the original to the scaled up reptile? I will be checking, this will be definitely a question I'm checking. I'm not going to go over it today. But I will check this on Thursday when you hand in your warm-up and exit tickets.